All right, architects, let's get right to it. I know you know the real challenge isn't just training a great ML model. Nope. The real work, the hard part, is getting that model into production where it can actually do something useful. So in this explainer, we're going to get into one of the most critical decisions you have to make, picking the right inference pattern on AWS. Let's dive in.
So you've done it. You've put in the hours, the model is trained, it's validated, it's ready for the big time. But deploying it, that's not just the last step. It's a huge architectural decision. It's got massive implications for cost, for performance, and, let's be honest, for your team's sanity. If you get this right, you unlock all that value you worked so hard for. But if you get it wrong, well, you're probably looking at blown budgets and some really unhappy users.
So here's how we're going to tackle this. First, we'll lay out the deployment dilemma. Then, we'll look at the three main paths you can take. We're going to put them head-to-head, compare them, and then walk through a practical guide to help you decide. Finally, we'll wrap up with how to architect your final choice.
At its heart, this whole thing is a classic architectural balancing act. You're constantly trading off things like latency, cost, and how much operational heavy lifting you want to do. To make this real, let's stick with one example the whole way through, a recommendation engine. Something that needs to be super fast. But how you get that speed, well, that's where the choices have some massive downstream effects.
On AWS, you've basically got three dominant ways to deploy a model, like our recommendation engine. And I want you to think of them not just as services, but as philosophies, each with its own personality. So, let's meet our contenders.
First up to the starting line, we have Amazon's SageMaker endpoints. This is your purpose-built race car. It is designed for one job and one job only, serving ML models with really low, really consistent latency. It's totally managed and optimized by AWS, which means you get to focus on your model, not the plumbing underneath. It's fast, it's powerful, and it's ready to go right out of the box.
Next, we've got the pickup truck of the group, running your model in a container on ECS or EKS. Now, this approach gives you absolute control and flexibility. You can haul anything you want with it, tweak the engine however you like, and plug it right into all your existing CI/CD pipelines. But just like a real pickup truck, you're on the hook for all the maintenance. You own it, for better or for worse.
And our third contender is AWS Lambda. This is the rideshare of ML inference. It just shows up exactly when you need it and disappears when you don't. The best part? You only pay for the exact compute time you use, right down to the millisecond. This makes it absolutely perfect for those unpredictable, bursty traffic patterns.
Okay, so we've met the race car, the pickup truck, and the ride share. Now for the fun part. Let's put them through their paces and really see how they stack up against the things that we, as architects, care about the most.
Okay, this table really breaks it all down. Let's walk through it. When it comes to latency, SageMaker is the clear winner for consistent, low-latency performance. Containers can be fast for sure, but you gotta tune them. Lambda, on the other hand, can be a little variable because of cold starts. Now, cost. This is a huge one. SageMaker and containers are provisioned, meaning you pay by the hour whether you use them or not. Lambda is pure pay-per-request. This is a critical difference. For operational lift, how much work your team has to do, containers are really high effort. It's all on you. SageMaker and Lambda, they're managed so the lift is super low. And finally, observationality. It's built right into SageMaker and Lambda, but with containers, you're building it yourself, which, hey, might be exactly what you want if you have existing tools.
And this chart just drives that cost point home beautifully. Look at this. If your traffic is sporadic, a few requests here and there, Lambda is just unbelievably cost-effective. Why? Because you're not paying for all that idle time. But if you tried to use a provisioned SageMaker endpoint for that same sporadic traffic, your costs would be way, way higher. Now flip that around. For constant heavy traffic, the provisioned model of SageMaker becomes so much more efficient. Paying for millions of individual Lambda invocations would get expensive fast.
Okay, so we've compared the options, we see the trade-offs, now let's get practical. How do you actually make a confident choice for your project? Well, it really just comes down to asking the right questions. So let's walk through a super simple three-step framework that's going to guide you to the right answer. Remember, this isn't about finding the single best service. It's about finding the best fit for your project's unique needs and constraints.
First step, analyze your traffic pattern. Is it steady and predictable, or is it bursty and all over the place? Constant traffic usually points you toward provisioned options, like SageMaker or containers. Sporadic traffic, that has Lambda written all over it. Second, define your latency budget. How fast is fast enough?
If you need rock-solid performance under 100 milliseconds, SageMaker was literally built for that. If you can handle a little variability, Lambda is a great option. And finally, be honest about your team's skills. Are they ML pros who just want to ship models, not mess with YAML files? SageMaker is their friend. Or are they DevOps wizards who live and breathe Kubernetes? Well, then EKS might just be the path of least resistance.
Whew! We have covered a ton of ground. So let's boil all this down into the most critical, most actionable takeaways that you can bring right back to your team tomorrow. It really boils down to this. If your number one top priority is raw, consistent speed without a lot of operational fuss, you choose SageMaker. If you need absolute, total control over the environment and you want to integrate with your existing container workflows, you choose containers on ECS or EKS. And if your traffic is all over the map and your main goal is saving money on those bursty workloads, you choose Lambda. Simple as that.
At the end of the day, all that incredible potential locked inside your machine learning model, it gets unlocked by this one architectural choice. This decision is the bridge from the data science lab to real-world business value. And now, you've got the framework to build that bridge with confidence. So, the only question left is, which path are you going to choose?